All right, so suppose something's going wrong. And in fact, we already solved the problem of like a lot of hashtags going this way and a lot of hashtags going that way. But suppose you want to wrap your mind around what your code is actually doing. It turns out that we have two other tools we can use. Turns out we have in the CS50 library a function that's almost identical to printf, except we called it eprintf, or like error printf, just to help you see what's going on inside of your code. And you should use it as follows. If you kind of want to wrap your mind more clearly around what your own code is doing, or for that matter, even an example from class that you downloaded, you can add certainly your own lines of this, like, hello there, I'm at home playing with this code, or something like that, right? So something nonsensical, but at least now, when you see that sentence on the screen, you know on what line the computer was executing your program. So you can be a little more methodical than this. And with eprintf, notice we can do the following. I'm going to change this to just eprintf, and it works the same. And I'm going to go ahead and do this about to prompt user for a number. Like, I just want to provide an explicit note to myself temporarily what should be happening here. And let me see now what happens. If I do make Mario4, OK, /Mario4, I get a little ugly output, but it's just diagnostic. It's temporary. It says Mario4.c on line 10 is giving the following message, about to prompt user for a number. That's just a note to self so that I'm comfortable understanding the flow or the structure of my program. I can still interact with it. Let's type in something like -1. And what should I see next on the screen if I type -1? Yeah, another problem, about to prompt user for number. So it's just like a sanity check. Like, if you think something's going to happen, tell yourself that it should in your code and make sure you see what you expect to see. And then once you're sure your code is good, then don't submit it with this, because this is not like correct per the specification. You can just get rid of it at that point. But frankly, that gets tedious very quickly. Oh, and how do I kill my program if I don't want to keep playing? Control-C will terminate the program. There's one other tool, perhaps the most powerful, and I can't stress this enough. Get into the habit of using this as needed early on. Even if it takes you an extra 10 minutes, half hour to play with it, it will save you potentially hours over the course of the semester. And that is a program called a debugger. So a debugger is a program that helps you remove bugs or mistakes from a program. And it works like this. I'm going to go ahead and recompile Mario4. And now I would normally run it, of course, with /Mario4. But suppose I have a bug, and I really want to understand what's going on. I'm going to do the following. You'll notice that all of my examples thus far have line numbers in the so-called gutter of the program, left-hand side. And it turns out you can actually click to the left of those numbers at like this point here. And you can put a red dot. This shall be known as what's called a breakpoint. This is like a little stop sign, only for yourself, that says, hey, computer, pause my program here, or really stop my program here, like a stop sign, temporarily. And let me, the human, go at human speed, not like billions of things per second speed. And by this, I mean the following. I'm going to now run not Mario4, but debug50 space Mario4, which again is a program we wrote that invokes or starts the IDE's built-in debugger. So notice magically, this right-hand panel just popped out. And it's actually always been there. It's always said debugger. And it just happened to open that window for me automatically. And let's see what's going on. There's a lot of words, but we're familiar with many of them already. Notice that down here is the word local variables. And then there's kind of a table here. It's not very big, because I only have one local variable. And at this point in the story, my variable n happens, I got lucky, it has a default value, it would seem, of 0. I shouldn't rely on that, but it's just so early in my program that it seems safe that it's, it's so early in my program that it happened to have the value 0 in it for our purposes today. And it's of type int. But what's cool now is the following. Now notice that my program is effectively paused on line 7, or specifically line 10, which is the first interesting line. That's why it's highlighted in yellow. And what's cool here is this. Up here in the top right, you have a play button, which will just say, play the rest of my program. Just let it go through without pausing. Or if I hover over this thing, you can step over this line, which means, hey, computer, execute this line, but at my human pace, just one line of code at a time. If you're really curious, you can step into that line of code, but more on that in just a moment. Meanwhile, this is step out, which is if we've actually dived in deeper. So what do I mean by all of this? So I'm currently paused on line 10, which was the first interesting line of code in my program so far as the debugger is concerned. I'm going to go ahead at top right, and I'm going to go ahead and click step over. And notice my terminal window is now prompting me for a number. Why? Well, because I've stepped over the get int line, which means execute it. So let me go ahead and type in that number. Let me go ahead and type in negative 50, enter, and keep an eye on the variable on the right-hand side. Notice now in the debugger, even without printing it with printf or eprintf, I can see that n has a value of negative 50. It's just a sanity check, so to speak. I can see what it is to be sure it's consistent with my expectations. All right, that's not right, so let me go ahead and step over. And notice the yellow line moved because it's looping. You can literally see what I keep doing with my hand. Let me do it again. OK, positive number. I'm going to cooperate this time, 42. Enter. Notice at the right-hand side, the value n is indeed 42. And notice the yellow line, if I keep stepping, is about to jump to the next interesting line of code. And if I keep doing this, watch what's about to happen in the blue terminal window at the bottom. There's the first hashtag. There's the second hashtag. So the sort of fake animation I did the other day with just my slides and what I try to do verbally and with my hand going back and forth, you can now see much more methodically. So even if it's a simple program, and even if it's code you wrote, you can really see step by step what it is your program's doing. And maybe it's not doing what you expect. And if it's not, you'll see it visually. All right, now I'm just going to go ahead and say, OK, print the rest of the thing. So I hit play. You see that the GDB, the new debugger server, is exiting. It's just quitting. And now I'm back at my prompt, and the debugger goes away. So do not undervalue those particular tools. So before we forge ahead, I thought I'd introduce Abhishek here, who you might have seen on the internet just a couple months ago. He kind of went viral. He's a recent grad from NYU. And he did this extraordinary thing. He took a device called a Microsoft HoloLens, which is an augmented reality device. It puts sort of a goofy-looking screen in front of your eyes, but then it projects images in front of your eyes. And it's really cool in that, much like an Android phone or an iPhone these days, it helps you, it knows where you are in a three-dimensional space. And what Abhishek actually did was he went to a very three-dimensional space, Central Park in Manhattan, and he had before that spent days recreating Super Mario Brothers in augmented reality by recreating one of those maps to which I alluded earlier. And the end result, and I'll show you just a glimpse of it, and we'll put it on the course's website for you to see later in detail, was this, which is pretty mind-blowing and a wonderful application of computer science to the real world, literally.
Hi, I'm Abhishek, and I've recreated the iconic first level of Super Mario Brothers as a first-person, life-size augmented reality game that I'm now going to play as Mario.
Abhishek gave a tech talk in CS50 a couple of months ago. And the funniest part, if you really look closely, and it is Manhattan, is like some people look at him, but like a lot of New Yorkers don't even look twice at what he's doing. Let's go ahead here and take a 5-minute break. And when we come back, we'll begin to look at the world of cryptography. So we are back. And of course, there are more functions than just printf. And we've seen a glimpse of these by way of the CS50 library. And there's many, many, many more that come with C itself and that other people around the world have written over the years. But implied in each of these CS50 functions, notice are these keywords like string and int and float, which we talked about the other day too, long and long and double, as we saw the other day too. So it turns out that C, to be clear, has what are called data types. And we glimpsed this the other day. Data types specify what type of data you can put inside of a variable. And that's what's different from Scratch too. In C and a few other languages too, you have to decide in advance as the programmer what kind of data are you going to put in this variable so that the computer, or really the compiler, knows. And so the compiler knows how to deal with it for you. Well, it turns out that if you want to print these things out, Printf also comes with certain format codes. And we've seen %s for strings and %i for integers. And there's a bunch of others too. Perhaps the most common would be these, just so that you've seen them. %f for float. We saw that the other day. %lld for a long, long decimal number. That's one I often have to look up myself. And then there's even more of those too. So just realize that as you're getting input from the users, whether for problem sets or any other purposes, realize that sometimes you have to check the manual or the documentation, so to speak, for functions that you're using. And so that you know where to turn for those kinds of things, let me just introduce one thing real quick. And you'll see more of this in super sections and sections and beyond. If you forget, for instance, how certain functions work, you can actually type the following. Man get underscore string, where man stands for manual. And this is kind of an old school command on Unix and Linux computers that have this text-based keyboard environment. And you'll see pretty much a standard structured user's manual for the function in which you're interested. So if you forget what we talked about in class, or you're not really sure how else you can use it, and the function is something like getString, you can simply read about it here. But sometimes, frankly, it's going to look a little arcane. I mean, we have not talked about what some of these symbols mean. The ... the word const, the asterisk that I've highlighted on the screen. So frankly, sometimes you will find the man pages, as they're called, the manual pages, just confusing unto themselves, which is a nasty situation to be in. If you're already confused and the documentation is not helping, you kind of need a third option. And so if you go to CS50's website, you'll actually find that there's a link to a tool that the staff has created over the years called CS50 Reference. This is a more user-friendly version of those same man pages, where we've gone through and sort of translated the very arcane English into less comfortable English, if you will. So if over here I scroll down to, say, printf, or rather let me just search for it, I can see printf here. It's inside of this header file, this H file on the system. And now I can actually read about it here. And notice at top right, checked is the less comfortable box, which means, hey, show me the language the TFs came up with as opposed to the default language. But it too is meant to be a training wheel. So if and when you're ready to sort of take away some of those simplifications, you can uncheck that box and now see the much more verbose technical version that you would actually see in the real world. So keep in mind those kinds of things too, especially if it feels like we go through things quickly in class, which we do, and you need to lean on something authoritative thereafter. But let's tease apart what actually a string is. Let me go ahead and start actually with Stelios here. So Stelios, one of our head TAs in New Haven, has this name here. And I've written it as a string, Stelios, but I've kind of drawn boxes deliberately around his name to capture the fact that this thing we call a string, like Stelios, is actually not really a string only. It's really like an abstraction for something a little lower level, which is a character after a character after a character and so forth. And so here too we see an example of an abstraction. Like it's not that much fun to call Stelios, Stelios. We call him Stelios. But we, in languages like C, would call that construct a string, or more technically a sequence of characters. But it's a string. It's a nice abstraction. It's a nice simplification. But it turns out there's an opportunity here now to see how characters and numbers interrelate in a computer and see how powerful computer programs and software are that we ourselves can write. But first, how do we access individual characters in a name? I can easily get Stelios' name using the function getString, as we've seen, just like Sam did from the audience the other day. But how do I actually get at like the S or the T or the E? Or if maybe he makes a typo, or maybe he like doesn't type it very neatly, how do I capitalize his name or sort of clean up his user input like websites today very commonly do? Well, let me go ahead and open up CS50 IDE again and just do a pretty simple example that this time involves strings. Let me go ahead and create a new file. And I'm going to call this file string0.c. And I'm going to go ahead now and write a short program. Come on, once I've lost control over my terminal window. Now I've lost control of my menu. This is my own fault for oh, here we go. Well, this is going to look great. Very inspiring here. Where'd it go? Oh, here. OK, that's an example of bad design. So we will fix that. And now I see that I've misspelled string as strig. So we're just going to, no one on the internet will ever know the following happened. OK, so string0, voila, here we go. All right. So string0.c, and I'm going to whip up a really quick program here as follows. So int main void, and now string s gets get string, and I'm just going to ask for the user's input in this way. And now I'm going to go ahead and print out, how about just say the word output here. And just to be nice and tidy, let me put a couple spaces here in anticipation. And now let me go ahead and do this. On line 5, my intention is to get like Stelios' name from him or whoever's playing this game. But now I want to go ahead and not just print out like hello Stelios and plug in his value s, which we've been doing. I want to do this character at a time. And doing something one at a time kind of suggests a loop. And indeed, I can do that. So I'm going to do for int I gets 0, I is less than however long his name is, and then I plus plus. And now I can introduce one other trick that you can kind of glimpse ever so quickly from the screen I had up before. Turns out that %c is the placeholder for a character. Perhaps no surprise. But the catch is I only have access to s, the whole thing, the string s. But it turns out there's a new piece of syntax here. And as is kind of sort of implied by our having used boxes to flank Stelios' letters of his name there, turns out that the equivalent in C is to kind of sort of do the same, use a box of characters by using the square brackets, which you might not often use on your keyboard. On a US keyboard, they're often just above the enter key. And here I can go ahead and type in s bracket I. And so to speak, this is going to print the ith character, if you will, of Stelios' name. So I is going to start at 0, and I keep doing plus, 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 plus. And using this square bracket notation, so to speak, I can dive into the individual letters in his name in this case. So when I run this, what's going to be the net effect? Let me go ahead and make string 0. OK, that is not valid C code, however long his name is. So I have a problem to solve here. How do I actually get the length of his name? Well, I can kind of cheat. So like, OK, so 1, 2, 3, 4, 5, 6, 7. All right, so we can just write this program as follows. 7, but this should rub you the wrong way. Like, why is this not a good solution to the problem? Yeah. Exactly. It's not changeable. I have this dynamism of get string to get Stelios' name, but 7 is not going to be true of all the humans who might use this program. I need something dynamic. Well, it turns out there is a function for that. I can call strlang for string length, pass in as input the variable whose length I want to get, and that will return to me a number, which will be, in this case, it would seem 7. But it's going to be dynamic, so if I type in like David, that should return 5, hopefully, and any number for any number of other humans engaging in this. So let me go ahead now and try again. Make string 0. A lot of errors and use of undeclared identifier string. Wait a minute, we've seen this before. How did I solve this last time? Yeah, what's up above missing? Yeah, the libraries, or the header files, so to speak, for the library. So I need to include, I'm pretty sure, at least standard.io.h for printf. I need to include cs50.h for getString. And we're almost there. Let me see if that's enough. Make string 0, implicitly declaring library function strlang with type. I don't really know what that is, but there's kind of an answer hinted there. Include the header string.h. And so forth. So turns out this is true. And you know, there's different ways to know this. If I actually go back to reference.cs50.net and do strlang, there's that function. Let me go back to the less comfortable version. Notice that under synopsis of a man page, or reference.cs50.net, is always a quick summary of how you use it. So just the prototype of the function that gives you a sense of what it is. Size t is essentially equivalent to an int, just saying the size of something is a number. But include string.h is the ingredient I wanted. So let me go ahead and copy that. Let me go back to the IDE. I'm going to be a little nitpicky, and I'm just going to keep things alphabetical at the top, but that's not strictly necessary. It just makes it easier to skim later on when the list gets long. Make string 0. Seems good to go. /string 0 inputs. Now I'm going to go ahead and type in Stelios' name. And I got his output as well. Now that was a lot of unnecessary work to print his name. I could have just used %s.